And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks within less than 5 minutes. So without wasting time, let's get started. Today's problem is allocate minimum pages, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So basically we will be given two things, two parameters. First one is an array ARR of integer type and another one is integer k. Okay, let's see what this signifies. So basically this array of integers ARR represent the number of pages in the ith book. Okay, all right, so what does this mean? This means suppose ARR has four elements and its elements are 12, 34, 67 and 90. It means there is first book has 12 pages, second book has 34 pages, third book has 67 pages and fourth book has 90 pages. Okay, all right, and after that what is this k? So basically k represents the number of students. Okay, k represents the number of students and what we have to do, so our task is to allocate books to each student such that, look, every student should have at least one book. Okay, every student should have at least one book, and no books can be assigned to more than one student. No book can be assigned to more than one student, and if two or three books is being assigned to one student, those books should be contiguous sequence of books, meaning continuous. You can say subarray. Okay, so suppose I will explain this. Let me explain this. Suppose this 12, this book is assigned to first student. 34, this second book is assigned to second student. Okay, 67, this third book is assigned to third student. Now 90 cannot be assigned back to second student. 90, like this fourth book with 90 pages cannot be assigned back to the second student. Why? Because second student, only each student is assigned a contiguous sequence of books. If I want to assign fourth book and second book, fourth book and second book to second student, then this book should also be assigned to second student because it should be in continuous. Once you left, you cannot give it back. Okay, all right, I hope this point is clear as well. So these three are our conditions, and one more condition is there. Basically, uh, no book is assigned to more than one student. Okay, now what is our objective? Objective is to minimize the maximum number of pages assigned to any student. Objective is to minimize the maximum number of pages assigned to any student. What does this mean? This means, suppose I have to assign these books, to students. Okay, I have to assign these books to student. Okay, so each student will have few pages, like few books, and books will be having some of pages. Okay, so if suppose first I assign first book to first student and next three books to second student. Okay, all right, so what will be the number of pages, maximum number of pages assigned to any student? Maximum number of pages assigned to any student, it is 191. Okay, all right, all right. Now I assign if I assign first two books uh, first two books to first and last two books to second student, so in that case, what is the maximum number of pages assigned to any student? That is 67 plus 90, 157, because it is 46 only. It is 46 and it is 157. So maximum number of pages is 157. Okay, so we have to minimize these maximum pages. We have to minimize this maximum number of pages. Okay, all right. So now what I will do, I will again try 12, 34, 67 first one and 92 second. Okay, so first three books are assigned to first student, last book is assigned to second student. In that case, maximum is what? Look, this is 90 and this is 113. Okay, so maximum number of pages is 113. Okay, all right, so we have to minimize it and we have minimized it. Okay, so minimum possible pages, maximum number of pages that can be assigned to a student, which is minimum, is 113. I hope this point will be very clear to you, and if yes, yeah, please let me know in comments. So I think the problem statement will be very clear to you. We have to minimize the maximum number of pages assigned to any students. Okay, all right, so I have explained it with one example as well. And one more thing, if you will read this note section, return -1 if a valid assignment is not possible. Okay, if a valid assignment is not possible, so you will be thinking, what can be the case when a valid assignment is not possible? Okay, all right, so let's move on to the next example, this one. 15, 17, 20 and k is equal to 5. Okay, all right, so here you will see number of students are 5. Okay, and books are only 3. Number of students are 5 and books are only 3. So can we assign 3 books to 5 students? No, we cannot assign, because one book can only be assigned to one student. one book can only be assigned to one student. Okay, so at least 5 books should be there to be assigned. So in that case we will return -1 because allocation cannot be done. Okay, all right. So I hope it will be very clear to you. If you want, we can take more examples as well. Let me take one example then. So now let's say 12, let's take this only, 12, 67, 34 and 90. Okay, all right. So these are the four books, and k is equal to 3 now. K is equal to 3 now. Okay, all right. So now how can we assign? Look, what can be the minimum pages, like what can be our lower limit? If you will see what can be our lower limit, so it will be the maximum pages in any book, maximum pages in any book. Okay, so for this it is 90. So beginning is 90. Now how it is the limit, how 90 is the minimum pages? Because look, 90 book means fourth book with 90 pages will be assigned to any student, will be assigned to any student. So 90 pages he has to read. Okay, so minimum possible answer, our minimum possible answer cannot be less than 90, because 90 pages at least one student have to read. Okay, so our minimum answer cannot be less than 90. Okay, all right. Upper answer, let's say end, what can be our maximum answer? Let's say there is only one student, let's say there is only one student. In that case it's all sum, 12, 67, 34, 90, its sum will be assigned to one student, and that can be our maximum answer. Okay, so 113 plus 90, what it is, 203, I guess. So 203. Okay, that can be our maximum answer. So now I've got our beginning minimum limit, I've got our end limit as well. So what technique are we going to use? Yes, you are absolutely right, we are going to use binary search here, because until, like, whenever I will get my min limit, max limit, and I have to get, and I am sure my answer will lie between those, so I will use binary search, I will use binary search. Okay, all right. So how we can use binary search here? So now suppose beginning is there, end is there, let's get the mid, let's get the mid. So mid is equal to what? 203, 90, 293. So it will be something like 146, I guess, 146. Okay, let's suppose if it is not correct as well, so leave it 146. Okay, all right. So if minimum pages are 146, can I assign it to 3 students? Can I assign it to 3 students? Okay, if minimum pages each has to, like, say, at least minimum pages, maximum pages one can read is 146. Okay, maximum pages one can read is 146. So can I assign it to 3 students? Let's see. So first one I will assign 12 to, like, say, first book I will assign to first student. Okay, after that second book will be assigned to first student as well, because minimum pages is 146. Okay, after that third book can also be assigned to first student. Okay, all right. After that, when I will assign it him 90, second book as well, in that case our sum will greater than 146, our sum will be greater than 146. Okay, all right. So look, in that case first student will read this one book. Okay, after that second student is 90, so it will read second. Okay, all right. So now you can see 2 students, so we do not need more than 2 students. If 2 students can be assigned, so 3 students can also be assigned. Okay, all right. So 146 can be our potential answer. Okay, 146 can be our potential answer. Okay, all right. So in that case we have to go down, we have to minimize the maximum answer, we have to minimize the maximum answer. Okay, so now in that case what will be our end? Now what will be our new end? It will be mid -1, mid -1, so it will be 145. Okay, all right. I hope this point is clear. So look, 146 are the maximum pages one student can read. Whatever mid is there, that is the maximum pages one student can read. Okay, all right. So here first student is can read these two, these three. Second student can read this one. So if 2 students can be assigned, 3 students can also be assigned. Why? Because let's say 12 is assigned to first student, second and third book is assigned to second student, and then fourth book is assigned to third student. So in that case also 146 is our nice answer. Okay, all right. So now what I will do is, let me delete all these things. Then our mid is there, and yeah. So now moving on, let's write it once again. 12, 34, 67 and 90. Okay, all right. So again we will calculate our mid will be what? 140, 90. 140 and 90 is what? 235. 235, I guess. So 235 divided by 2 is 117, 170. Okay, all right. So 117 is the maximum number of pages one student can read, and there are three students, so don't take this test case, it is not related. K is equal to 3 for now. So first book, second book, third book can be assigned to first student, and the last book can be assigned to second student. Okay, all right, so 117 is also our answer, because if two students can be assigned these books, three students can also be assigned, okay, with 117 as our maximum answer. Okay, again we will lower our limit, so now our end will become what? Our end will become 160. Okay, now again let's calculate our mid. So mid will be now what? 206. Okay, so again our mid will be 103. 103. Okay, again we will check, can I assign it to three students with 103 as our limit? Okay, all right, so first book is assigned to first student, second book is assigned to first student, can third book also be assigned? Let's see. So 34 and 12, 46. Okay, 46 pages are already assigned, and then 103 is the maximum limit which can be assigned. 103 is the maximum number of pages one student can read. Okay, so if I will add 67 to it, it will become what? 113. It will become 113. So no, I cannot assign 167, this third book, to first student, otherwise the limit will exceed. Okay, so first book will be assigned, like say two books will be assigned to first student, second book will be assigned to second student. Okay, so now at this point total number of pages read by second book is 67, second student is 67. Now can I assign my fourth book, to second student? No, we cannot assign, because 90 plus 67, it is greater than 103. Okay, all right, so now third book needs to be assigned to third student. Okay, all right, it is still fine. You can see if our maximum answer is 103, it is possible. Again we have to decrease it more. Okay, all right, so again let's say our beginning is still 90. If you remember, beginning is still 90, end is now what? It was 110, I guess. So now end will become 102. Okay, because our mid was 103, our mid was 110, I guess, or anything you can see. So end is now 102. Okay, all right, and now number of pages is 12, 67, 12, 34, 67, and 90. So in this way we will keep on checking our minimum and maximum. I hope this point is very clear to you. In this way, our beginning is this, end is this. Again we will check if it is possible to add to like minimize our maximum number of pages. I will decrease our end, and otherwise if number of students are increasing, so in that case what we have to do, we have to, let's say what, we have to increase our limit. Okay, all right, so if I will say something like if we will take another example, let's say it is 12, it is 14, it is 19. Okay, all right, and now two students are there, I have to assign it to two students. Okay, all right, so minimum will be what? Minimum will be 19, beginning will be 19, end will be what? The sum of all these three, 16, 26, 36, 45. Okay, so beginning is 19, greater maximum is 45. We will calculate our mid part. Again we will check, can two students be assigned books in such a way that our maximum pages one can read is mid. If yes, we will decrease our limit, otherwise we will increase. Okay, all right, I hope this point will be very clear, and when I will write the code of it, it will become more clear to you. So if you have loved the approach, if you have got the approach, please subscribe the channel, because subscribers are not increasing, and it motivates us when the subscribers increase. Okay, all right, second point which I wanted to discuss with you is, should I increase in Hindi or English is fine? Because I want to keep it as professional as it is, so that it helps you in interviews as well. Okay, all right, so that's why I explain in English. Let me know if you want me to change. Okay, all right, so now let's move on to the code section. So first of all, what I will do, guys, look, if our k is number of students, is greater than arr dot length, in this case what I will do, I will return -1, because it is not possible. Okay, all right, after that what I will do, let's say for now our beginning is 0 and our end is 0 as well. Okay, I will run a for each loop. It's a for each loop, and now what will be our beginning? If you remember, beginning will be the maximum of all these number of pages. Okay, so beginning is equal to, let's say, math.max of beginning comma I. Okay, and end is what? Maximum limit is what? Sum of all pages. Sum of all pages. Why? Because if k is equal to 1, if k is equal to 1, our answer will be sum of all pages. Okay, all right. So end is equal to, let's say, end plus equal to I. Okay, so end is equal to end plus I, something like this. Okay, after that our answer for now is beginning, but let's take it 0. Our answer cannot be less than beginning. Okay, so beginning can also be our answer. So if you want, I can write something like this as well. Okay, all right. After that, while simple loop, binary search, while beginning is less than equal to end, what I will do first, int mid is equal to beginning plus end divide by 2. And now what I will check, if it is possible, if it is possible, so I will pass three things. First one is ARR, second one is our K, number of students, third one is our mid. Okay, all right. So now this will check if this maximum number of pages is like K students can read these or not. K students can read. So if yes, in that case, what I will do, I will simply take one answer, update our answer is equal to mid, because I've got a greater answer now, greater than beginning for sure. And now what we have to do, we have to minimize our answer. So to minimize our answer, we have to go left side. And how to go left side? End is equal to mid minus 1. Okay, all right. Otherwise what I will do, otherwise it's very simple, beginning is equal to mid plus 1. Okay, all right. So these two are there, and after that, coming out of this loop here, I will simply return answer. Okay, so this is our first thing. Now we just have to write our is possible. Now we have to complete our is possible function. How are we going to do that? Static boolean is possible, and first one is our int ARR, second one is int K, and third one is our, let's say, uh, minimum max count. Okay, max pages, let's say. So this is our maximum number of pages which one can read. It cannot be greater than it. One student cannot read more than max pages. Okay, so this is something. And now what I will do, look, total students. So for now total is equal to 1, because at least one student will be there, and how many pages it has read is 0. Okay, all right. So what I will do, I will simply use a for each loop, int I a rr. And now what I will do, very interesting it is to, you should see. So first of all, what I will do, sum plus is equal to I, meaning number of pages one has read is increased by I. Okay, but now if our sum is greater than, max pages, it means I have to assign this book to another student. Okay, so now another student is also used, and now number of pages that new student has read is equal to I. Okay, all right. So this will keep on going, and at last here what I will do, I will simply return if my total number of pages is greater than or equal to K, it means it is possible. If our total number of pages, total number of students is let's say is less than equal to K, it means this number of students can read our book, can read our all the 4 books with this limit. Okay, with this limit, so it is fine. And now I will decrease our minimize our answer and again check, okay, all right. So yeah, in this way we will keep on doing. And I just want to have one more example, but let's first of all submit this to check if it is running correctly or not. Meanwhile, please subscribe the channel and like the video if you have loved the explanation. I think it is getting accepted. So yeah, I just want to give one more example before shutting it, before closing this. Then there is 25, then there is 30, then there is 30. Okay, all right. Now let's say for any point our mid comes as 31. Let's say mid comes as 31. Okay, and K is equal to 2. K is equal to 2, like number of students are 2. So is it possible, to for 2 students to read 3 books, and no students read more than 31 pages? No student read more than 31 pages. Okay, so first student will read 10 first book. Okay, now 25, if he reads second book as well, number of pages he will read is 35, which is greater than mid. Okay, all right. So now first student cannot read second book. So if you will see, sum is greater than max pages. If I will take second, yes, so in that case total will be plus plus and sum is equal to I. Okay, so it means second book is read by second student. Okay, now third book, third book can only be read by third student, not second. Okay, all right, because it will again become 55, which is greater than mid. Okay, all right. And after that, at last, what I will check is total is less than equal to k. Total is what? Three students. I need three students, but given students are only two. Okay, so 3 is less than equal to 2. No, it is not correct. It is not correct, and I will return false. I will return false. False means is possible. It is not possible such that our minimum answer is 31. Our answer is 31, and 3 and 2 students can read all these books. Okay, so what we have to do? We have to maximize our answer now. We have to maximize our answer. How? Beginning is equal to mid plus 1. Okay, in this way we will keep on doing, and if at any point our let's say students are able to read this mid pages, it means we have to now minimize our answer. Int is equal to mid minus 1. In this way it will keep on going, and I hope it will be very very clear to you. If yes, so please subscribe the channel, and I've made a very cool Chrome extension for you. Its link is in the pinned comment, so please download it as well. I'm going to see you again tomorrow. Till then, keep on coding and